I'll attempt to continue. Numbers of flowers per cluster. I talk about this in general. Just a quick anecdote here. A friend of mine is a consultant. He was working with a greenhouse tomato grower, I believe in Ohio. And this greenhouse tomato grower was, had the Kool-Aid. He was on the system. He was taking his soil tests. He was doing his mineral balancing. He was doing his inoculation again, like my friend Liz. And he was doing what we call the saturated paste test, which is the in-season soluble nutrient soil test, which tells you what's available right now for your plants. And he got his report back, and the report said low on manganese. And so he said, well, I know what to do about this. Took his manganese sulfate, he solubilized it in water, watered it into the soil, felt really proud about him, patted himself on the back. Went to bed that night, woke up at 2 o'clock in the morning.
I forgot to mix the carbon.
He put 10 times as much manganese as he was supposed to. There was no carbon. He did the math wrong and put 10 times as much manganese in as he was supposed to. And manganese is a soluble salt, and too much trace elements will fry things, and this was his cash crop, and he got all worked up. He called my friend up and said, what can I do? And he's like, well, you've solubilized the salt and you've watered it into the soil. You can apply humic acid. You can put something in to buffer it, but you've definitely, the train has left the station. We'll just have to see what occurs. And what occurred was that the next time that tomato plant flowered, or those tomato plants flowered, instead of having 4 or 5 flowers per cluster, there were 12 to 15 flowers per cluster. Manganese is, Carrie Reeves would call it a female element. So it's a strong reproductive energy. Generally, when you see that the flowers are decreasing, the numbers of flowers are decreasing, that's actually correlated with a manganese deficiency. This guy was on the program. He had, good base calcium levels. He had good biological activity, et cetera, et cetera, et cetera. Those flowers all pollinated and set fruit, and functionally he tripled his yield in that flowering cycle by overdosing his plants on manganese. Functionally, because the plant had the capacity to deal with it, actually that manganese was a limiting factor. I've got written on the soil test, on the reports, 80 to 90 parts per million manganese, which is generally considered to be quite a high target. It's not a high target if your plants are healthy, because they need it to manifest the levels of fruiting, which is their potential. Anybody ever seen a cherry tomato cluster that had 100 fruit on it? Literally, like one frond with 100 fruit on it. A friend of mine did this little experiment with overdosing plants on manganese, right? I say stuff like this, and you're like, yeah, okay, Kittredge. So we took a handful of manganese sulfate and dumped it down at the end of the row of his tomatoes and said, let's see what happens, cherry tomatoes. And he sent me pictures of his cherry tomato plant with literally more than 100 fruit on a frond. Ridiculous, ridiculous, ridiculous.
We got it in those plants we were going to airstream
Mm-hmm.
with the colors.
Yeah.
When I did the tissue test, it was high. Manganese was one of the excess, but I had put it on, but it said in cold anaerobic soil that can't go in.
Yeah. There was definitely anaerobic, and they're tight. Yeah, totally. Anyway, experimenting with these things is also a fun thing to do. Take a little bit of extra potassium, overdose one section of the field with it, and see what happens. That's another good way to learn what happens.
You can do it with a bucket. As I told you, just go throw a bucket out in a few days, and if you put down something that's soluble or whatever, like you'll know
see
it's wrong or it's right or yeah.
If you got
And
enough
then you know
land,
what
if
to
you got,
buy,
if you got
you know what
enough
to
enough
order.
land to play with, right? The nature will tell you. You can send tissue tests off if you want, or you can just experiment. Throw a little bit of this down here, throw a little bit of that down there, throw a little bit of this down here, and see what happens. There's all kinds of ways to experiment. If there was a good handbook on this whole topic, I would think I would have heard about it by now, and I'd be happy to tell you. What I can tell you is there's an amazing amount of opportunity here, and I have not been able to coalesce it into much coherence. I'm giving you the best that I've got.
We use the little, the fertilizer, the conventional fertilizer thing that goes on your hose. So
Yeah.
we'll just stick that on the hose or something and then
Yeah.
you kind of play around with the diet.
Spray some potassium down, spray some manganese down, spray some phosphorus down, spray some potassium down. You can totally do it. What weed families are present? Not individual weeds, but general trends. Okay, fine. All right, so now we get to the next few pages, which are specific minerals and their specific symptoms. Before I read that, I want to read this one slide. Biochemical process of plant nutrition. This comes from a guy named Hugh Lovell, one of the better commentators on biodynamics that I've come across. Hugh Lovell lives in Australia currently. He spent a lot of time farming in Georgia. But A Biodynamic Farm and I think Quantum Agriculture are his two books that really go into a lot of these things. And from a biodynamic perspective, for those who are curious about biodynamics, I think it was the best book I've ever read on biodynamics was A Biodynamic Farm, a good comprehensive conversation. And then Quantum Ag really integrates the mineral balancing with the energetics. Really interesting book for those who are looking for Quantum Agriculture. Hugh Lovell, L-O-V-E-L is his name. I think they're both published by Acres USA Press.
I think they've set up a certification for Quantum now, right? To rival Demeter.
Is it?
I think so.
I don't know. I saw him give a 3-day course last month, and he didn't say anything about that.
I might be wrong then.
There's discussions of it. They're trying to push the envelope. Various people are trying to push the envelope with different labels, but I don't know that there's anything formal about it. There's this regenerative conversation going on too. People talking about regenerative agriculture.
Right.
Yeah.
Vermont has a certified regenerative now.
Is it certified or is somebody proposing something?
And it just went through.
It passed?
Yeah.
Yeah.
And Siskiyou Seeds that we mentioned yesterday is a biodynamic seed.
Yeah, for what it's worth. Okay, boron activates silicon, which carries all other nutrients, starting with calcium, which binds nitrogen to form amino acids, DNA, and promote cell division. Amino acids form proteins and tag trace minerals, especially magnesium, to form chlorophyll, which transfers energy via phosphorus to carbon, to form sugars, which grow up potassium carries them. I don't know if anybody else finds that a bit overwhelming. The one point I want to make by reading that is that everything's connected to everything else. Everything's connected to everything else. So we can talk about calcium deficiencies, but the first bullet point in the calcium deficiency says, oftentimes calcium shortages show up in tandem with other shortages, most commonly boron and silicon. The first line in this previous slide, boron activates silicon, which carries all other nutrients, starting with calcium. If you don't have enough calcium in the plant, but you've got enough calcium in the soil, the issue may not be to add more calcium because it's not, the calcium doesn't carry itself. It's the boron which facilitates the calcium mobility. Generally, when you see this big leaf at the bottom of the plant and small leaves at the top of the plant, that's a symptom of calcium deficiency, which is not caused by a lack of calcium. It's caused by a lack of boron. It's the boron which facilitates the calcium mobility. Even if you've got enough calcium in the soil, it's boron which is the issue in so many cases. It can be, but in almost everyone's case, boron is deficient.
Yeah.
Just about everybody's case,
So
boron
that's
is deficient. Every single case, boron is deficient. Let me say that 3 more times. In every single case, boron is deficient. You don't need, if you're not going to take a soil test, you mean well, but you know you're not going to follow through, get your hands on some boron and get it out there in the ground. Just about everybody needs boron. Maybe in a hoop house, you don't. Maybe in a place where it doesn't rain, you don't. If you've applied boron in the past,
But I'm nervous about it, because it keeps
You
saying
should
if
be
you-
nervous about
If
it.
you put too much boron on it,
yes.
you're screwed, but you've had it.
Yep.
Because it's not gonna come back out, it's just gonna, so I've really been
It,
nervous
it,
about boron.
it's an
but I know I
anion
have a
and it
boron.
leaches.
So it's your sap, if your plant tissues have it in it, and if you know.
I'll teach you how to, I'll give you a test for boron deficiency in a minute. I'll give you a test for boron deficiency. You can use it with a refractometer in a minute.
Oh, good.
Yes.
Okay, so we're all deficient, but what do we need to be at? I mean, mine says 0.27.
I gave you a target of 3 yesterday on the handout.
Oh, that's
So you are formally at about 10% of where you need to be, which means your yields will never pass 10% of what the genetic potential of your crops are.
Do we have the thing that you read aloud that started with boron carries all other nutrients by calcium?
You should.
Page 4.
Top of page 4, we're moving right along
You
here.
read some- you read-
Top of page 4. That smells. Stem and leaf strength and ability to flex and bend are correlated to calcium. When things are brittle, you don't have enough calcium. Strong cell walls, which correlate to fungal resistance, happen when you've got good calcium levels. If you've got fungal susceptibility, if your blights and mildews are taking your crops out, you are not getting enough calcium into your plant. Roundness of stem is a sign of good calcium presence. Leaves that have a wrinkled appearance and may defoliate are a sign of a calcium deficiency. Anybody ever seen a green Swiss chard leaf? You know, the Ford Hook giant green chard starts off in the spring with this big, beautiful, broad, glossy leaf. sometime by the middle of July, it's got all ruffled. You seen that ruffle? It was flat, now it's not.
Yep.
The ruffling is a sign of a calcium deficiency. Ever seen a ruffle on the side
grass
on a
does it
corn
too.
leaf?
We were looking at kinks and folds.
A corn leaf with a little ruffle going up one side and
Yeah,
down the
goes
next?
like this, yeah.
That ruffling, that savoying is a sign of a calcium deficiency.
And twisting,
Yep,
twisting,
it's,
I guess the leaf is twisting.
yeah. Poorly developed root hairs, you don't usually dig up your plants to see what the root hairs look like. Young leaves that die back at the tips, also a sign of calcium deficiency. Adequate calcium correlates to the same leaf size across the plant. When the leaves get smaller and smaller, that's a functional calcium deficiency. Adequate calcium will help the plant vibrate at a higher frequency, increasing the plant's ability to pull nutrients to it. You can take that one or leave it. I think it's true, but it's hard to test. Leaves will curl upward in a calcium shortage in cucurbits and become brittle. This also correlates with a boron deficiency. Vine crops will become resistant to powdery mildew with sufficient silicon. Anybody ever had their winter squash leaves turn white and then turn brown and then die? That's called powdery mildew. Ever had your summer squash leaves do that? Ever had your cucumber leaves do that? That's called powdery mildew. You will not have susceptibility to powdery mildew with sufficient silicon. Silicon and calcium are needed to build strong cell walls, which are impenetrable to fungal hyphae. They cannot penetrate the cell wall with a good, properly built cell wall. They simply can't do it, and silicon is critical for that purpose. I gave you the target level of 50 on the soil test as for silicon. I suggested when your soil test levels are below 50, it's a good excuse to use some rock dust. Anybody know what a good biological form of silicon is?
Horsetail.
Horsetail. Equisetum, horsetail. You can make a horsetail tea. It's a wonderful way to get a really biologically available form of silicon. You can spray it into your plants. You can water it into your plants. Really wonderful. Horsetail is a very, very primitive plant. It doesn't have leaves. It's like
You
90.
can get that now, you can buy horsetail.
It has leaves.
They aren't really leaves.
Okay.
So it was
They're like-
silicon and what, the squash?
Silicon is, calcium and silicon are critical for building strong cell walls. And the calcium is moved by the boron. It's the boron that's the death of you. It's the boron that's the death of you. It's the
Boron.
boron is massively important. Massively important. Sure, you should be afraid of putting on too much. It's a wonderful weed killer. It's your organic farmer's herbicide. Right, if you've got a patio where you got grass growing in the patio and you want to kill it, a little bit too much borax will take it out good. Right, what do they use for pressure treating wood these days? Boron. Right? Boron is, well, a lot of it is boron. If you've got a patio
Yeah, heard that.
with grass growing in between too much boron is a really good killer.
Yeah.
So you should be afraid of it. You should be concerned about it, absolutely. But I've given you recommendations for quantities that are not too much, right? And generally, having a good calcium level in your soil will buffer against almost everything, and good organic matter levels in your soil will buffer against almost everything. And whenever you're worried about something burning things, you mix it with a carbon source, and that'll prevent it from burning things.
Humates have a very good source of available silicon in.
I did not know that.
What does?
Humates.
Oh, humates.
All right. Grasses and cucurbits especially need silicon. Silicon supplementation will cause leaf hairs to increase in size and vibrancy. Anybody knows about leaf hairs? Leaves with hairs on them. Some tomato leaves are hairy and fuzzy. Some tomato leaves are not. Some eggplants build this thorn on them that you can draw blood. Some eggplants don't have anything on them. The fuzzier the plant, the better. The hairier, the better. The more the stem looks like it'll prickle you, the healthier the plant is. Right? In general. Those are functionally antennae. Boron facilitates carbohydrate transport down to the roots and nutrients up to the leaves. Insufficient boron will correlate with a stagnant Brix reading in crops that does not fluctuate during the day. All right. Time for a picture.
Equisetum a hydric plant? It looks like I've never grown it or anything, so I just looked it up and it looks aquatic.
No, grows in very dry areas like along the railroad track.
Yeah.
Oh, really?
Very barren.
Piles
It's a
of
very
dry
deep
rock.
and prehistoric type
So
of
we
plant.
could grow it ourselves if we
You
wanted.
can find it, growing around. I just found it last week at a farm.
Cool.
I'm going, I
Sorry.
asked him if I can go back and harvest it summer.
I don't see much of it around. I've seen it in piles of, rock dust and sand and stuff like that is where I've seen it growing. But you said you saw it growing in the wetlands. Yeah.
What is it?
Horsetail, it's called.
Okay.
There's
It's a
bunch
very,
of them.
very, very primitive plant. It's like a 500 million year old plant. It doesn't really have leaves. It looks like a pine tree in its shape. It's like it's got needles, but they aren't needles. They're,
It was that kind of plants and ferns that probably made these humate deposits, and that's probably why they're high in silicon.
and the ferns from those deposits were 80 feet tall.
Yeah.
Those are real full-on ferns. Yeah. Imagine what we could do with a little bit more global warming and some good nutrition. We could cause all of our plants to grow like that. We really could. Right? How big were the dinosaurs? I mean, like, we could, if we figure out how to use biological systems, we could do amazing things. We can modulate plants. It's going to get really exciting. I think it's, all right. So I was going to talk about bricks. So I gave you the picture for the conductivity before, and I said you'd like to see it generally move up and maintain through the growing season, and when it goes down, there's a sign that something's wrong, and you should get in there and work on your conductivity. This is a 24-hour cycle here with the refractometer and bricks. So we'll call this 7 a.m. We'll call this 3 p.m. And this is 7 a.m. again. You should have a 1 to 2 point differential between these two. I should probably tell you what bricks is first, before we get too far down this road. And if you don't get this kind of a path, if you check it at 7 a.m. and 3 p.m. and 7 a.m., if you don't get this up and down, if you get something that looks like this, where your bricks reading is like this, try it, wait for a sunny day if you want to test it. If your bricks reading is stagnant, that means you've got a boron deficiency. Real simple. Okay, what is bricks? What is refractometer? Why is it important? People have heard about it. I haven't talked about it. This is a refractometer. Let's start with Brix. Brix was an Austrian chemist. He won the award put out by the German vintners in the 1830s. The German vintners had this issue, which was that they were trying to make wine because they were vintners, and they kept making vinegar. They would harvest their grapes, crush them, ferment them, stick them in the barrels, stick the barrels in the catacombs, pull the barrels out 20 years later, and they'd be full of vinegar. And they were like, oh! Right? And it just kept happening because barrels are big and, they cost money to make, and the catacombs are holes in the ground that are a hassle to dig out. And it's, they were hoping to get wine in their barrels, and they kept finding vinegar in their barrels. And sometimes it'd be wine, and sometimes it'd be vinegar, and they couldn't figure out what made them sometimes be vinegar and sometimes be wine. And so they all got together, and they made a $1 million prize. They said, it wasn't $1 million obviously, but whoever can figure out how to predict what grape juice will make wine and what grape juice will make vinegar, we will give this prize to. And Brix is the guy who figured it out. Brix figured out that it was a specific gravity of the juice that correlates with the quality of the wine. The more viscous, the more dense, the more stuff in the juice, the better the quality of the wine. The more watery the juice, the more likely it would turn into vinegar and not to wine. He won the award, and he got a little chart named after him. People may have heard of Richter, you may have heard of Fahrenheit, you may have heard of Celsius, right? You know about all these guys? Right? They were just European men from the 1800s who figured something out and got a chart named after him, or a scale named after him. So Brix is another one of those European men from the 1800s who got a scale named after him, and that's called the Brix scale, the Brix chart. There's oftentimes a misunderstanding when it comes to Brix, and people think that Brix is testing sugar. And that is absolutely, categorically, entirely not true. So I want to explain to you what Brix is testing and why we think it's important when it comes to crops. It is not a be-all and end-all, but I think it is one of the simplest, easiest, least expensive modes for analysis of how your crops are doing if you're being intellectually honest. So what a refractometer is measuring is refraction. Refraction is the bending of light. If you stick your hand in a bathtub full of water, it'll look like it bends. We know this. It's not bending. It's just the light that's bending when it passes through the water. If you stick your hand in the ocean, it'll look like it bends more. It's not more bent. It's that the light is bending more when it's passing through the water with salt in it. The salt in the water causes the light to bend more than it would if it was just passing through water. There's no sugar in the ocean. The light is bending. We're getting a Brix reading in the salt water. There's no sugar. So what a refractometer measures is how much the light bends when it passes through a fluid. When you put 1 drop of water on here, you should see it go to 0. That's 0 Brix is pure water. The calibration to Brix is a sucrose calibration. So the amount light bends when it passes through a 1% sucrose solution is called 1 Brix. The amount light bends when it passes through a 5% sucrose solution is called 5 Brix. The amount light bends when it passes through a 10% sucrose solution is 10 Brix. That's the calibration. Like Celsius is 1% of the distance between frozen water and boiling water, right? Freezing water is 0 Celsius and boiling water is 100 Celsius, but the air is not boiling. But when we say 70 Celsius or 60 Celsius or 40 Celsius, we're not measuring the temperature of water. It's just that the scale is set to that, and then once we've got the scale, we know what that means. So, so the way you get a Brix reading on a crop is really simple, and what you're measuring is what are all the juices in the crop. And basically, the more stuff in the juice, the more minerals, the more amino acids, the more proteins, the more, all these nitrates, et cetera, in the sap, the more the light bends when it passes through it. Certainly sugar is one of the compounds in the sap that's causing light to bend, but it's not the only one. So we're not measuring sugar. You can put a drop of vinegar on a refractometer and get a reading. You can get a drop of, olive oil on the refractometer and get a reading. Drop of battery acid on the refractometer and get a reading. None of those have,
All right, we're good.
well, none of them have sugar in them, and all of them give you a reading, which makes the point that you're not testing sugar. So anybody who tells you the refractometer is testing sugar is lying to you or is ignorant or is, being disingenuous at the best. I know a lot of people who know better who tell people that the refractometer measures sugar, and it's not true.
This is what
Minor
the
pet
question
peeve.
was, just about the Brix nutrition
Yeah.
animals, is like that we were getting high Brix
Yeah.
on some of the plants, and the animals were not performing well, and that when you said it, the nitrates or things, like I also know it was parallel in the minerals maybe in the solution, but it doesn't mean the minerals were in balance. Like if one mineral is in
Yes.
excess, it could be a high Brix.
You got an anaerobic situation, and you got toxicities of certain elements, and,
Yeah.
and the animals are not responding well.
The grazers are all teaching me the Brix, and everyone's
Yeah.
thinking higher is better, and I'm like, well, I'm just kind of trying to understand it so I can
So-
explain to it better. It's like, it's generally a good sign, but it doesn't mean it's healthy. It just means.
So there's
it has
cloudy
stuff in
line,
it.
there's cloudy line Brix and flat line Brix. That's one nuance I should go into. And then there's the overall numbers. So first, the thing I want to do is I want to show you how to get a Brix reading, and then we can go into other nuances. So what I suggest you do when you're growing your plants is one thing you can do is you can take a Brix reading, every Tuesday morning at 7 when you're taking your walk. Get your refractometer in one pocket and your conductivity meter in the other. Take a Brix reading, you take a leaf, you put it in here, you squish it, and here comes a drop of juice. It's that easy. And you look at it, and we've got about a 7.5 or so. You see it? That's yours, you've seen it before.
Look toward the lights.
What's that?
Does she need to look toward the lights?
It's bright enough in here.
I just had a question about stored food or produce, because sometimes
Yeah.
I wonder if I could take samples, and then by the time I walk back, it might be an hour,
Yeah.
I don't have the meter with me or something, I see something on the sample, with those leaves that have been here for a day or two.
In water,
How
yeah.
much do you expect? I mean, is it
So Brix,
predictable how much it would lose over time?
Brix is really good if you're being intellectually honest. And there's really easy ways to cheat Brix. Like if you dehydrate a leaf. right? I mean, you can take a leaf fresh and you can get a Brix reading on it, and it'll be 4, and if you let it wilt for an hour, the Brix reading will be 6. So, or 8. The more wilted something is, the more the water has left it, the more the dissolved solids are concentrated, the higher the rating gets. So Brix, if you want to cheat, is really, I mean, is doable. You can cheat Brix. It's not hard to do. If you're being intellectually honest, if you really are trying to be, empirical and get a baseline and see where things are moving, it's a valuable